Hello and welcome to this video where we're going to be looking at section 2.1.4 of Representation of Data in Computer Systems of the OCR computing specification, and in particular we're going to be looking at ASCII. OCR say that you need to be able to explain the use of binary codes to represent characters, explain the term character set, and describe with examples, for example ASCII and Unicode, the relationship between the number of bits per character in a character set and the number of characters which can be represented. So here we have a nice image stolen from the internet which explains the use of binary codes to represent characters. So you can see there's 127 different binary codes and they tally up to different things. So for example 01, 000, 111 is an uppercase G. We can look at 0011 00000 is equal to 0 in ASCII. So this means we can represent letters quite easily using binary codes, and again those binary codes can be used as octal, can be used as hex, can be used as decimal. But what OCR want you to be able to look at is explain the use of binary codes to represent characters. This can come up in exams quite often where it gives you some binary codes and it tells you to work out what the binary codes would be for the letters, for example BAC. A character set is a defined list of characters. So for example, a character set converts a binary number into a written language character. Sometimes a big mistake which happens is that people think that has things to do with fonts. Nothing to do with fonts. Always remember, defined list of characters. So for example, ASCII is a character set. Here we're going to be looking at describing examples, for example with ASCII and Unicode, the relationship between the number of bits per character in a character set and the number of characters which can be represented. And we're going to be looking at 4 different examples here. 7-bit ASCII, which was the first version of ASCII which was released, had 128 different symbols possible. So if you take a look down at your keyboard, 128 symbols. And remember, those 26 letters of the alphabet, you've got 26 uppercase, 26 lowercase, it soon gets filled up. 8-bit extended ASCII then doubled it to 256 symbols possible. So then we can start to look at different foreign languages. So for example with the French, with their accents above letters, if you think about Russian letters, they're very different from the standard UK letters which can be used. Unicode was then brought into play, and the amount of symbols possible, it just gets crazy. So 65,500 symbols possible with 16-bit Unicode. 21-bit Unicode can have over 1.1 million. So if you're looking at 21-bit Unicode, suddenly you can draw upon many different things. So for example, ancient Greek lettering, hieroglyphs can be used with 21-bit Unicode. The larger the amount of bits, the more symbols allowed, which means the greater tolerance it has for different people. So for example with ASCII, if you asked, for example, someone in China to write their name using Chinese lettering, they wouldn't be able to do it because it doesn't have it in there. Whereas if we're starting to look at different versions of Unicode, it does have them in there, it is allowable. I hope this has been helpful for you. Feel free to like, comment and subscribe, and I'll see you in a future video. Bye bye.